Welcome back. We're gonna start today's lecture. Before we start, I would like to call the attendance. So I'm just gonna briefly repeat the introduction because there's a new student and we're not gonna do it anymore. This course is called the General Purpose Engineering Computation Tools. Grading policy is 75% assignments, 25% participation, and this lecture series accounts for 40% of total grade. My name is Unjin. Again, I'll talk about tutorial for overall CFD analysis processes, and CFDs are important for these reasons. We discussed about how general tools should be, and we wanted to efficiently manage our resources. Again, for the first 6 weeks, it's going to be my lecture series, and from the 7th week, you will have different lecture for different lecture series. So you can see after my class, you're going to learn my lecture. You're going to learn Python basics, introduction to plasma chemistry, accelerator-related basics and programs. So this is basic idea. Be present to the class, please. According to POSIX grading system, if you're late for the class 3 times, it counts as 1 absence. So please, again, grading policy. This class is really generous. So unless you skip all the classes, it's gonna be all fine. And for my lecture series, I upload every material that I use. So if you can follow everything and then get the STL file exported, then it's gonna be all great. Yes, so that's the introduction. I'm gonna briefly go through what we're gonna do today, and then you can follow along. So, 없습니까?
네.
그럼 제가 따로 드리겠습니다.
감사합니다.
그러면, so basically for this lecture, we're gonna learn Onshape. Onshape is an extremely powerful tool for computational aided design, and we're gonna sign in to Onshape and then use it for our drawing purposes. So today we're gonna draw 3 objects. The first one essentially looks like a toy, like this. The second object looks like a rod with some holes in it. And the third object is heatsink. So the main functions we're going to learn today are, for example, hole wizard and extrusion and fillet. As you can see at the edges, we're going to learn fillet, and then we're going to also learn construction lines, and then mirror and drafted extrusion, and then what else? And offset at the same time, and then we're gonna learn how to make a drawing out of it. Also, we're gonna learn linear pattern. So later, if you have any questions, please ask me. It's gonna be all great. So far, so I'm gonna go through what we're gonna do today very quickly, and then if you can download the material from PLMS, please do so. And while I'm just giving introduction to the material, if you can just follow along, then just draw the material, and then once you're done, you can just raise your hand and probably leave as well. Don't forget, if you don't do these, don't create these objects and then don't submit these, and then these are going to count as your homework grading. So please participate in the class. So the first object we're gonna do, also first of all, we're gonna sign into Onshape, and if you have email. It's very useful. If you don't have access to Wi-Fi, please use this password. We have installed a new Wi-Fi just dedicated for this class, so please use them. You can sign up with your information. Your affiliation will be post-tech, and I just randomly wrote nuclear engineering, even though my affiliation is mechanical engineering. And we're going to create a new document called tutorial 1. So you can see there are 3 perpendicular planes, and you can see there are small coordinate axes here, and then you can move these axes. And if you click some of these, you can change the direction or the point of view. So first of all, what you really have to do is to change the units. If you don't change the units, at the end of the addition, you're going to have to redo every material. So please change the units. That's the most important thing. Always, when you create a new document, please go to workspace units. This one uses imperial system, so please change to millimeters. And then there are different functions for right click and left click and wheel. So if you can right click, you can see functions of the plane or the object. So 2 important things we do is we view normal to it, and then we create sketches. So once you create a sketch, what you're seeing is there's a sketch plane that you can draw on. The top plane is an object plane, so it's immutable, so you can't really change it. But the sketch plane is where you can create objects. So this is the principle by which this application works. So you're going to create a sketch plane, and then you're going to draw sketch objects. So what you can notice here is in the function, in the wizard bar, there used to be 3D like objects in the wizard bar, but you can see they changed to sketch objects. So first, we're going to sketch a corner rectangle. We're going to draw these, and if you see these values significantly lower, it means you haven't set up the workspace units correctly. So please always check the workspace units, and once you check these workspace units, make sure they are confirmed. And also, what's really important is this origin point has its own constraint. So if you click the origin and draw it, one of the sides will be fixed to origin, or in the worst case, both of the sides will be fixed to the main coordinates. So you're going to draw these. Draw this rectangle first, and then you're going to use the distance or measure function, and then you're going to type in the measure of this. And because this is a rectangle object, you're gonna set its height and width. So the height will be 50, width will be 40. So, and then you're gonna change to rectangle of 40, 15. And then you can see if an object becomes, so if these are not constrained, they turn out to be blue, but if they are constrained, they turn out to be black. So you can show constraints and then see if they're immutable or not. So here, because we have set up the measure of each side, you can see every side has become black, and we're going to extrude it. Extrude means we're going to make 3D object out of 2D object. So when you click extrusion over here, you're going to see this gray like hypothetical object in the space, and then you can change the depth. And then there are three main functions we use. We don't really use intersect, but if you declare a new object, it's going to add up to the previous material, but they're going to consider separately. But if you add a new object, then they're gonna merge, and then they're going to be considered one object. This is extremely important because when you later export this material to STL file, the STL file will create surface triangles, and then if it's one object, you can't really change the colors of each material. So, and remove is of course remove. So whenever you click extrusion, make sure there's specific depth to it. Here we're going to use 5 millimeters and extract it out. So once you're at this point, you can rotate this material using right click of your mouse, and then you can get rid of the front and right planes. So you can right click the plane and then hide it, or you can go to this left side panel and then remove them. So once you're at this point, you're gonna sketch on a side. So here you're gonna click the side, and then once you click the side, the face will look like an orange color. So you're gonna right click and sketch a new object. So you can also see parallel to this face, you're seeing a sketch plane number 2. So this is a separate plane compared to the first sketch 1 plane. And if you double click the sketch 1 plane, you can edit the sketch. So make sure if you want to edit previous objects, you can edit the sketch, and it's gonna cascade all the way to extrusion. So for example, if you want to change the base geometry of the extrusion, you can just change the sketch, and then it will extrude right away. So anyways, of course we're gonna view normal to it, and then we're gonna draw a rectangle and then set up the sizes. So by setting up sizes this way, you can see this rectangle is coincident with this rectangle at the center. So you're gonna draw a circle here. If the phi is 15, then it means they also have the same length diameter. And then you're gonna get rid of the internal lines using the scissors. So if you get rid of the internal lines, you can see this connected sketch object. And then if you confirm it, you can see all these lines are perfectly blue. So you can drag these and then change its size, etc. So at this point, you're gonna extrude this object again. So make sure you're not making a new object, you're making merged object. So you can see this side completely merged with the previous object. And we're gonna apply hole wizard. Hole wizard applies on holes, aka points. So if you can drill every single point, and then what's important is to sketch the holes. So you're going to sketch the holes, draw 2 points, and then change its locations, and then you're going to apply the hole wizard, and yes, you're going to make this simple hole. But also here you can draw another point, and then based on this location, you're going to draw a counterbore. You're going to create a counterbore hole object. So you're going to have 2 different or multiple different radii for the holes. So once this step is over, you're going to make a new sketch and remove the bottom of the extruded object, and then we're going to smooth out the edges. So by clicking fillet, you're going to smooth out the edges, and it's always better to smooth out the edges, otherwise the edges are where the thermomechanical stress accumulates. So once you're done with this, you can just click, or you can just click the surface, and then it's gonna fillet every edge, relate to it, and you're done with the first object. So we're gonna follow this step, and once this step is over, you can export the material and then export it to STL file. And make sure you have the correct units, because an STL file is a combination of surface triangles. So if you choose wrong units, it's going to be enlarged disproportionately. Anyways, once you're done with this, you can just take a look, and these are the files that you're going to submit for homeworks. Part of the homeworks. Yes, so please follow along, and if you have questions, please let me know. There was an update for the fillet function, so in the material it says cross-section being circular. Now it's control distance with radius 3 millimeters. So yes, it's almost the same. Oh yeah, you fillet vertically and I fillet horizontally. You can see it here. Okay, we're gonna move to the next one here. So we finished the first one, so I hope you export it. If you haven't finished, you can continue doing this after me explaining this material. So anyways, so we're gonna create a new object, create a new project called tutorial 2. Make sure you use underscore instead of space. Underscores are much more useful than space. Here we're going to start from the top plane. Make sure you have the units correctly. The units have to be in millimeters. So here you're going to click top, and of course you should hide two other planes. So what we're going to do is, instead of drawing a single rectangle, we're going to use a construction line, and we're going to mirror the objects and then create a rectangle eventually. So there's not really a specific procedure to it, but we chose construction line. I chose construction line to demonstrate how it works. So construction lines are hypothetical lines that you can't really extrude. Construction planes are the planes that you can't extrude because they don't really exist. It's only for the reference. So probably if you're using this application in Korean, construction line is called 기준선, so it has the same meaning. But anyways, if you have the right units, you're gonna be able to draw these three lines. What you can see here is the horizontal line is in black, meaning it's constrained by the parallelism between the construction line and this horizontal line. So you will draw three segments of the line, and then you're gonna use mirror sketch. So by using mirror sketch, you're gonna have to collect objects that you're gonna mirror, and then the construction line, the axis that you wanna mirror to. So here we're gonna choose the construction line as the mirror entity. These three line segments is mirror entity, and then construction line is the line of sort of reflection. So anyways, once you're done with this, you can edit this, and then if you mirror this again, for example, you can see this sort of rectangle can be mirrored. So you're going to choose this side. It doesn't have to be particularly long. It can be of any length, and then you can still mirror this. So once you're done with this step, you can remove the unnecessary lines internally, so you can trim them. So here you're gonna extrude that, but also with a draft angle. So here, what's really important is you're gonna draft it. You're gonna make it symmetric and give it 8 degrees of draft. So here you can see slightly slanted geometry here. So it looks very pretty. You're gonna choose a perpendicular plane. So here, what you can see here is even though we suppress the right plane, we can still sketch on them. So you're gonna right-click the right plane and then create a new sketch and then view normal to it. So you're gonna draw a circle. Make sure this is a right plane. Again, this is perpendicular to the original object. So, and it's perpendicular to the direction in which the original object was extruded. So you're going to extrude it, and once you're done with this, you're going to extrude it very long, 350 millimeters. and then you're gonna add it so that you can see them in the same extrusion panel. Anyways, for the top plane, you're gonna add a new sketch and you're gonna draw points just like what you did for the whole wizard, and you're gonna measure the distance so it's what was it, has like enough distance from the end, so it's gonna have 18 millimeters distance, and then you're gonna create a center point arc. So this is really hard. This is the hardest part, I think. So we're gonna create center point arc here first, and then center point arc here, and then you're gonna connect these with the lines. Again, by clicking center point arc, you can make an arc. You can make an arc here as well, and then you're gonna give this distance. If you see them unnecessarily constrained, you're doing it wrong. So please remove it and start from the beginning. So for these two lines, you can see there is no constraint to it. So if you make tangent, you can see everything completely in black. So it's very smooth, right? It's smooth. Wait, I'm sorry. I don't know where the material is. Oh, anyways. So once you're done with this, give me a sec. I think it's because my file ran out of space. Yep, so here once you create this smooth line, make it drafted again. This time the draft degree is 6 degrees, and you're gonna add it to the original material. So also here it's also symmetric, so you're not just drafting to one direction, you're gonna have it to the opposite direction as well. And once you're done with this step, you're normal to the top plane, and then you're gonna make an offset. Offset is a function that helps you to create the periphery of the surface that you choose. And then for here, if you choose the offset, you can make the same geometry that has the same distance from the outer edge. So here the distance from the outer edge is 2 millimeters, and then you're gonna extrude it, so you're gonna cut a bit, and then, well, once you're done with this, you're gonna make other circles in the domain, and then you're gonna remove it. So, and then, yes, you can see these two holes, and then on top of them there are larger holes. And then once you're done with this, you can make drawing out of it. So you're gonna make ASI B format millimeter drawing. So at this point, you can make it scale to 1:3, and then you can add dimension so that the readers can get some help from you. Yes. So once you're done with this, we're gonna have some break. But also, before we move on to this material, I wanted to give you very useful information about Onshape. So if you go to Onshape, you can open Onshape, and then what's really useful is, so you can go to the public panel on the left. So if you click public panel, you can see everything other people have shared. So for example, if you type in nuclear reactor, you can easily see other objects people created. So for example, yep, you can see the preview of it. So you can either open it, open a new, I hope you can open it in a new browser tab. And then once you open it, what it usually says is it's a view only object. So you should copy to your own workspace. So you're going to copy, because this document is owned by someone else, even though it's public, so everyone can view it. You have to copy to your own workspace. For example, sorry, my bad. If you can copy to your own workspace, my copy, then you can copy document to your own workspace. Anyways, you're gonna copy all the material here. SLDPRT came from solid part, so it's the mutable object that you can edit in your workspace. So once you're done with this step, you can go to your own workspace and then see the copied material here. So you can see, for example, here, now you have it in your workspace. You can, change the sketch, etc., and then see if you need anything. You can just copy paste what other people do. That's a really powerful part of using Onshape, especially when you're required to draw some materials that you don't really feel familiar with. This is extremely powerful to do, because usually what we do is, for example, what we would do is nuclear reactor STL file, and then hope someone might have made it for you, but you don't really have to do it. In this case, you can just go to the public workspace and then copy it into your workspace. Also, another thing I want to introduce you to is the concept of STL file. What you can see is, unlike our material here, this one's completely drawn from scratch. So you can see these are just extruded objects. But here, what you can see here, what you can see is small triangles constructing the entire surface. So you can see every part of it is triangle, right? So here, everything is triangle. So you can see, if you import other STL files, they are all in this triangular shape. So this one is triangular, and also this one is also all in triangular. So it's really important to know that these triangles are scale invariant objects. So if you don't set up the millimeters or the workspace unit correctly, then you're gonna see it like unnecessarily enlarged or upscale. So anyways, this is the second object. If you have questions, please ask me. And yes, I think it's all. Again, here the cross-section circular function doesn't exist anymore, so please choose distance and see what the all rates. Anyways, I'm going to tell you how to do the tutorial 3. In these planes, of course, you're going to choose a top plane. You're going to create a corner rectangle and then make this in this specific size. It's really important to dimension them correctly. So you're going to extrude them. Of course, on top of it, you're going to create a new sketch. This example is really easy. So you're going to create a small rectangle that attaches to the edge of the bigger rectangle. And then once you're done with this rectangle, you're going to create a linear pattern. So linear pattern can just go through, can copy the object to x-axis and y-axis at the same time. So here you can see these hypothetical objects copied here, and you can scroll them and drag them to increase the number of them. You can use the wheel to scroll. So if you change the number of copies, you can see the number of copies here, and then you can make the linear pattern both in x and y axis, x and y direction. So you're gonna have all these sketches done, and then at the center you're gonna select these rectangles and you're gonna delete them. And with this space, you're gonna first you're gonna extrude out the original copied pattern. And then on top of it, you're gonna draw at the center these small fins. So you're gonna also apply linear pattern. So you're gonna fill out the linear pattern. It fits perfectly within this domain. So once you're done with this, you're gonna extrude it again and export it, and it's gonna be all good. So if you're done with the material, you may leave. I don't wanna hold anyone back. You don't really have to stay until the end, but I generally recommend finishing the material during the class. You can do it at home, doesn't matter. But yes, have other questions, please let me know. And if you don't, we can officially end the class here, and then yes, we can just go through the questions and answers.